I'm working. Nothing. I was working on getting you guys an example here. Can't do that. It'll be a strong pass. Sorry. They would, but I would not. So I want to get into a couple examples here today, and then give you some time to work on an assignment. But I want to start with one of the questions we talked about yesterday, or something similar to yesterday, and then we'll show one more or a varied type of this. So I at least show you three examples. We'll work through three examples, but each one's going to be a little bit different than the previous. So this one we talked about yesterday. We have bases here that are different, correct? So if the bases are different, our first strategy is to see if we can rewrite them so that they're the same base, right? The easiest thing to do is look at the smallest number and think, okay, I'm going to let that be my base. And if I'm going to let that smallest number be my base, then how can I take, essentially in this case, the 9 and rewrite it so that it has the same base? So how can I rewrite 9 so that it is a base of 3? Okay, so 3 times 3, so I'll write it as 3 squared. Okay, and that's going to give me then 3 to the 8x minus 7 over here, right? That's called a one-to-one relationship, one-to-one correspondence. Because the 3's are the same now, what can you tell me that those things have to be to one another? Yes, they have to be the same too. So we have to set those equal to each other. And we are going to get then 8x minus 7 is equal to 2. Add 7 to both sides. 8x is 9. Your answer then, x is 9/8. What, okay? Okay. Those are the examples we saw yesterday. Now, I want to show you something a little bit, maybe a little bit more difficult. Let's say we have 9 to the x squared times 3 to the 7x equals 81. Okay, we got a lot of garbage going. It's an ugly looking equation. But there's 3 bases up there. What are the 3 bases that are being provided up there? 9, 3, and 81. Okay, 9, 3, and 81. Do they have a relationship with one another? The smallest one is 3, right? Can I rewrite all of them so that they have a base of 3? So obviously 3 to the 7x would be 3 to 7x. We'd leave that alone, right? What's 9? I'm going to rewrite 9 so it has a base of 3. 3 squared. So that 9 right there is going to change to 3 squared. It still has that x squared with it. Okay, so we'll talk about that here in a moment. And does anybody know what 81? Close. 3 to the 4th. Okay. Now, what do we do with a power to a power here? Multiply them. So we get 3 to the 2x squared plus 3 to the 7x equals 3 to the 4th, correct? And this one's kind of a pain in the butt because on this left-hand side, we have a product of 2 bases that are the same, right? we have a product of two bases. What do you do with exponents? Like let's say I had like 3. If I had 3 squared times 3 to the 5th, how would you rewrite that? You would add them. You would say 3 to the 2 plus 5, but most of the time we just write it as 7, right? That's the same thing going on here, but I can't just add those and get one concise value like 7. I'm going to have to rewrite this as 3 to the 2x squared plus 7x. Does that make sense? I have to just do that because there's no like terms there. That is then equal to 3 to the 4th. Okay. Now, because you have one base on the left and now one base on the right, and those bases are the same, what can you do with those exponents? You can set those equal to each other first, right? Okay, so you got that relationship. So now this whole problem gets transformed to us being able to answer this question. 2x squared plus 7x equals 4. Now, all the equations we've done so far with this, when we compare the exponents, they've been x to the first. And we solve those because they are linear equations, we solve them using opposite or inverse operations. Here we have an x squared. If you remember what we want to get on this side of the equation if there's an x squared in your problem. I don't want to square root everything right away. Because if I do that, I'm still going to have x, and I'll have the square root of x. I won't be able to isolate and solve just for x by itself. Because remember factoring? If this is a 4, I want it to become a 0. So I'm going to subtract 4 from both sides. Yes. So I get that. Okay. Now, at this point, you can do a couple things, and we'll go through this algebraically by hand. Then we'll go to the calculator and see if the calculator can present us with some information as well. Basically, what we'll want to do is see first, does everything divide by that 2? And that 7 won't divide by 2, right? So we take the 2, we did this, we take the 2 and multiply it by the -4, and it gives us -8. And now we're thinking about two numbers that multiply together to give me -8, but add to give me that +7. Would you agree that 8 and -1 multiply together to give me -8, but their sum is +7? So what we're going to do then is we're going to rewrite that 7x as a sum of those two things. So I'll say 2x squared plus 8x minus 1x minus 4 equals 0. If you remember then, what we did is we grouped those two things, and then we grouped those two things. If I look at the first set of grouping, what do these two terms, 2x and 8x, have in common? What are they both divisible by? 2. But are they also both divisible by x? So I take a 2x out. And when I take a 2x out, let's say take it out, I'm factoring out, I'm dividing it out. If I were to take 2x out of 2x squared, what's that leave me with? Just x. Okay? If I take 2x out of 8x through division, what's that leave me with? 4. And now the second grouping, okay, they don't both divide by a number like 2 or 4, but what is the thing that they do divide by? Okay. So what do both these divide by? -1. Good. Okay, so I'm going to divide by -1. That's going to leave me x plus 4. And then we remember, hopefully, that when these are the same, when these sets of parentheses are the same, that one factor is x plus 4. That's what was those parentheses. And the other factor is what was outside the parentheses. We put that together as 1, so 2x minus 1. And what that does, so that factored the original problem. If we were to FOIL that, take x times 2x. It gives you 2x squared. Take 4 times 2x, it gives you 8x. Take x times -1, gives you -x. So we add those together, I get 7x, which was in the original problem. And then 4 times -1, last times last, gives me -4 as well. So now we have a product of two things that equals 0, a product of two things and they equal 0. So that means x plus 4 must be 0, or 2x minus 1 must be 0. And then x is -4, and x is 1/2. Those are my two answers. Okay? And to check that, because we've done a lot of work, right? So I think it maybe makes sense when you do that amount of work, did we do it all right? So we'll type in 9 to the, I'm going to use a, but 9 to the a squared. And then we'll times that by 3 to the 7x. And basically what I want to see here is, does this end up, or not x, 7a. I want to type in a. Basically what we want to do is, does this end up giving me 81 when I type in these two results of -4? So I plug in -4 as a. So a, struggling here. A equals -4. Did it give me 81? Okay. And then when I try 1/2, did it give me 81? Okay. Now, question is, will this be on the quiz tomorrow? It might. It very well could be. This is previous information, right? And this is what I guess it's a great opportunity for us to talk about this as we go through a math class. I've mentioned this before. When we see something, we are seeing it in the order that we see it intentionally, okay? Because we saw factoring early in the year, right? You dealt with factoring in Algebra 1, okay? You may have done a little bit of factoring in 8th grade. And the reason that you do that you see that early, is because it is a driving force for a lot of mathematics beyond that, okay? So it's going to come up over and over and over and over again as we go through our future math classes. So the idea is, and I know it's a bad assumption, but the assumption is, when I see something in a math class, when I go through it, talk about it in class, we test over it, we quiz over it, not everybody is going to master it, okay? But the assumption from the author that is going into the next section, they have to have this assumption, is that you have mastered it, and you can use that in the next section, or the next chapter, or the next textbook, or the next course. Does that make sense? Okay. And that just, I think, explains I think the main characteristic that is different about math courses than any other course is that you cannot forget. You cannot make the assumption, I'm not good at this. I'm gonna weather the storm, and I'm gonna wait till 2 weeks, 3 weeks, and be done with it, and never have to see it again. Because inevitably, you're going to see it again. Okay? Does that make sense? Now, my hope is that I've tried to show you maybe some techniques in the past, because I know, I get it. That's hard. Okay? So there are techniques that we can use to help us out with this. First technique that I think I would probably turn to is that if I recognize that, I know that is quadratic equation. You guys remember seeing this thing? X equals the opposite of b plus or minus b squared minus 4ac over 2a. Remember that? Okay. That thing gives us these answers. And basically, you can either do it by hand, but my suggestion to you is to grab your calculator. Grab Desmos. You have to type this in. I have to go negative b. Now, there's not a plus or minus, so I'll have to do this in 2 steps. But then type in the b squared minus 4ac. We'll divide that whole thing by 2a. Okay, so we've got that thing. I'll cut and paste it. And this is what I was saying, we have to do it in 2 steps. I have to put the minus there. Okay. And now I have to define what I want A to be. I have to define what I want B to be. And I have to define what C is going to be. Okay. Now, does anybody remember from this what A, B, and C are? A is 2. B is 7. C is negative 4. And if I can remember that, does it spit back my 2 answers of 1/2 and negative 4? Is that a little bit easier? Okay. There's an alternative approach to it. Okay. You can actually type in on the graph y equals 2x squared plus 7x minus 4. And the solutions that are present here are the x values of where the red parabola crosses the x-axis. Negative 4 and 1/2. Does that make sense? So you've got gave you the analytical approach, the algebraic process here by hand, which is cumbersome. Okay? But if you can do that, I think it allows you to understand these things a little bit better. Okay? But if you understand these, then maybe those are the starting point for getting us to be able to do the stuff by hand. Okay? My hopes that what we understand here, what we see here, is that just because we're working on exponential equations, and I'm trying to get you to see that the base has to be the same so we can make the exponents equal, depending on what those exponents are, might get you to solve an easy equation, might get you to solve a very difficult equation. And sometimes they might even get you to solve equations that don't have solutions, or maybe even equations that we've never seen before. Okay? And that's the thing that I think is important to see here. Let's do one more. Let's say, we'll do a little bit easier, but we have to use a property that yes. So let's say we've got four to the 3x equals 1 over 64. This one's a little bit trickier because the thing that we've talked about so far is because of the way the bases have presented themselves in all our questions so far is we always look at the smallest number and try to get the other one to be written in terms of the smallest number. When you have a fraction, you kind of reverse that, okay? Because the smallest number up there is 1/64. It's going to be really hard for us maybe to rewrite the 4 so that it looks like 1/64. Okay? So we're going to adjust this a little bit. If you get a fraction like this, that 64, my hopes are that we can see maybe there is a relationship at least between 4 and 64. Okay? If I go 4 to the first, what's 4 to the first? 4. What's 4 squared? 16. What's 4 cubed? 64. Okay? So there is a relationship between 4 and 64, right? We know that 4 cubed does equal 64. So that's going to be useful for us. Okay? Can I do this? Well, let's do it this way. Let's show you numerically. If I go 1 divided by 64, okay, is that the same thing as 64 raised to the negative 1? Does that give me the same exact values back? Does that make sense, everybody? And we've talked about that. If we usually don't write that 64 in the bottom with that exponent of 1, but we can. And if I have something on the bottom with an exponent and I want to move it to the top, move it to the numerator, then I need to change the sign of the exponent, right? Now, traditionally, if we don't like negatives because we don't want to leave our answer with negative exponents, right? But there's the times that we're working our intermediate processes that negative exponents actually become very useful. So if I rewrite this as 4 to the 3x equals 64 to the negative first. And what that does is it gets rid of the fraction, right? So now, can I rewrite this as 4 to the 3x equals, let's employ this now. That 64 can be rewritten as 4 to the third, right? That would be rewriting the 64, but it should still have that exponent of negative 1. And if I'm uncertain if what I've done here, the way I've transformed this, was appropriate, I can always take 4 to the third, raise it to the negative 1, so it still give me 1 over 64. Okay? So I know that this is all okay. Now, when we've seen this previously, you got a power to a power, right? What can you do with those two things? Multiply them. So then I'll have 4 to the 3x equals 4 to the negative 3. So now that the bases are the same, I have now 3x equals negative 3, right? So what's x going to be? Negative 1. Is that okay? If I put negative 1 in here, think about this. Go 4 to the 3 times negative 1 will give me negative 3, right? Do we like negative exponents? Nope. So I'd rewrite that as 1 over 4 to the third. So what's 4 to the third? 64, which is exactly what we had there. So you might, and I just want to show those 3 because as I select questions for your homeworks, a couple of those types of formats pop up. Okay, so I want to make sure that you have at least an example to reference. All right, so I'm going to assign. It's called